Hello everyone, welcome back to this channel. If you're new here, my name is Hasan. Let's begin our 12th part of the video series. In this video, I'll be discussing about the concept of refraction in prism. Now, there are certain new terms that we need to learn like angle of prism, deviation angle, and we will check how this angle of prism and deviation angle are related to refraction angle. Then we'll be looking into the concept of refractive index, the formula for refractive index in prism. After that, we'll jump into the concept of thin prism and how the formula of refractive index changes when it comes to the concept of thin prism. And finally, we'll be looking into some of the numerical problems and tricks to make the concept super solid, so that whenever this kind of question comes up, like the concept of prism is asked in exam, then you can easily smash those questions. So without any further delay, let's jump into the video and build our concept. But before that, let's roll the intro. So let's start our study on the concept of refraction in prism, and let's look into the definition of prism first. It says that it is a solid, homogeneous, transparent medium bounded by two plane surfaces inclined at an angle. So as you can see in this figure that there are two surfaces and those two surfaces are inclined at an angle. The two surfaces are this yellow shaded color, the yellow shade that I've given. Okay, these are the two plane surfaces and which are kept at a certain angle, and that angle is known as angle of prism, which I have written here, that is known as A. Okay, you can see that this angle is actually the angle between the two refracting surface. Now, why it is known as refracting surface? If you look here, light rays will come and incident here, then it will get refracted, and then again it will incident on this part and will undergo refraction again. So these two surfaces are known as refracting surface, and the angle between this refracting surface is actually known as angle of prism. I hope this is clear, because angle of prism plays an important role here. Some of the formulas are derived in terms of angle of prism here, so that is a very important parameter here. Now let's understand more deeply what is angle of prism. For example, this is our prism. Okay, if light enters like this and then after refraction it moves in this way, then in the second surface it refracts again and moves in this way. So we can see that, let me pick another color. This is the first refracting surface and this is the second refracting surface. So the angle between them is the angle of prism. But if the ray of light is coming in this way, suppose, okay, and then it got refracted in this way, then after refraction, if it moves away in this way, okay, then we will say the angle of the prism is this one. This will be the angle of prism. Why? Because the refracting surface now is this one, as you can see. Let me pick another color. Now this blue one is actually the first refracting surface and the second one is this one. Okay, I hope this is clear. So the angle between the two refracting surface is actually the angle of prism. I hope the concept of angle of prism is now clear. This is all about the definition of prism and angle of prism and refracting surface. Now let's move on to our next concept, that is angle of deviation. Now let's look into the concept of angle of deviation, which is denoted by delta, as you can see here. Okay, so it is denoted by delta. Now what does angle of deviation actually means? Let's look into this diagram and things will be clear. As you can see that this is the incident ray, okay, and it fell on the first refracting surface. Okay, so this is the first refracting surface, as you can see. Now after the refraction it moves in this way. As you know that the prism is made up of material that is optically denser than air, therefore the rays move towards the normal, as you can see. Then again it falls onto the second refracting surface and then it moves out of the prism following the concept of refraction. Okay, this angle, the angle at which it leaves the prism, is known as angle of emergence, because the rays are emerging out of the prism. Therefore that angle is known as angle of emergence, and the angle with which it enters is known as angle of incidence. Now the original path of this incident ray, if you look into this incident ray, the original path is this one. I'm extending the original path of the ray. Okay, so this is the original path of the incident ray, but we can see that the rays, when it moved out of the prism, it is actually following this path. Okay, I'm drawing it with green color. Okay, so this is the emerging ray. So if we extend this back side, then we can see that actually this path was the original path. Okay, this was the path, but now due to prism and refraction the path has turned in this direction. Therefore we can say that the ray has deviated by this much. Okay, therefore this angle is known as deviation angle. I hope the concept is clear. It is basically saying that by how much angle the ray has turned from the original path. Okay, that angle by which it has changed its path is known as angle of deviation. I hope the concept is clear, and it is denoted by delta. Okay, so our target is to find the magnitude of delta. Okay, so let's see how you can find that. In order to find the angle of deviation, what we will do is we will take into consideration this triangle. Now be very careful. See, this is the point of the triangle, suppose D, and this is suppose Z. Okay, so we'll take into consideration triangle CDZ. Okay, so from the property of triangle, we know that if you know the property of triangle, we have learned this in class 9-10 maths, that if this is the triangle ABC, then the exterior angle is actually the sum of the opposite interior angles, isn't it? So we can say that angle C, that is exterior angle C, is equal to angle A plus angle B, isn't it? So we'll be applying this concept in this triangle CDZ. So you can see that the deviation angle is actually the exterior angle C, isn't it? Therefore, the exterior angle is equal to the sum of the interior angle. Therefore, we can say that the angle of deviation is actually angle D plus angle Z. Okay, in the triangle CDZ. So our target is to find how much is angle D. Okay, now if you look into the figure, then we can say that angle D is actually I minus R1, isn't it? Because if this is angle I, then this whole thing has to be angle I, which is known as vertically opposite angle, isn't it? Therefore, we can say that angle D is actually I minus R1. Okay, this much is clear. In the same way, we can say that angle Z is equal to E minus R2. If this is angle E, that is emergent angle, then vertically opposite will be this angle, isn't it? Therefore, we can say that angle Z is equal to E minus R2. Therefore, now we can say that delta is equal to I minus R1 plus E minus R2, isn't it? Now if you look into this figure, what is R2? R2 is the second refraction angle. See, I have measured that from the normal. We know that the refraction angle is always measured from the normal. So this is actually the normal to the second surface, and the angle of incidence or the refraction angle is this one. We have measured it from the normal. So R2 is the refraction angle for the second surface, and E is the angle of emergence. So we can arrange this thing and write that I plus E minus, take it as common, then we can say that R1 plus R2. So we got the value of delta as I plus E minus R1 plus R2. Okay, this is clear, but we are not done yet. Let's see, we will move on. Now we will consider that suppose this is point A, this is point D, this is point M, and this is Z. Let's take into consideration this quadrilateral, that is, consider quadrilateral ADMZ. Okay, let me rub this off in order to make more space. So there's a property of quadrilateral that sum of opposite angle is equal to 180 degree. Okay, sum of opposite angle is equal to 180 degree. Therefore, we can say that angle A in the quadrilateral, okay, in the quadrilateral, angle A plus angle M should be equal to 180 degree. Now, if you look into the figure, angle M is actually 180 degree minus R1 plus R2. How we got this? This can be found out from the triangle DMZ. If you consider triangle DMZ, then we can see that angle R1 plus angle R2 plus angle M is equal to 180 degree. Therefore, from there we found out that angle M is 180 degree minus R1 plus R2. So simply we'll put the value here, the value of M here, to find the angle of prism. Okay, so let's see. So if we put the value of M in the equation, this equation, then we will get angle A is equal to 180 degree minus angle M. Therefore, you can say 180 degree minus of 180 degree plus of R1 plus R2. So 180 got cancelled. Therefore, we got a very important relationship between refraction angle and angle of the prism, that is A is equal to R1 plus R2. So very important. Now we got two important equation. One is delta is equal to I plus E minus R1 plus R2, isn't it? This was the formula that we have derived here, okay? And we saw that A is equal to R1 plus R2. Now, if we replace the value of R1 plus R2 with A in this equation here, then we can say delta is equal to I plus E minus of A, isn't it? So this is another formula. So these are the formulas which are very important when it comes to the concept of prism. So you need to remember these two formulas, that is the formula for A, that is angle of prism, this relation, and this relation, okay, that is delta is equal to I plus E minus A, where A is equal to R1 plus R2. These are the two formulas which are very important, and this will help to solve MCQs very quickly. Okay, now let's look into some of the numerical problem in order to solidify the concept. Okay, so let's look into this problem. The angle of prism is capital A. One of its refracting surfaces is silvered. Light rays falling at an angle of incidence 2A on the first surface returns back through the same path after suffering reflection at the silvered surface. The refractive index mu of the prism is, now four options are given: 2 sin A, 2 cos A, half cos A, and tan A. This was asked in the year 2014. So let's see how to solve this. And remember one thing, that in NEET they will never ask question that can't be solved within 1 minute. Okay, maybe there are exceptions like 1 or 2 questions, but most of the questions can be solved within 1 minute. So let's see. I'll show you a trick how to solve this within 15 to 20 seconds. But before that, let's understand the concept and the traditional method. It says that a prism having angle, that is angle of prism as capital A, one of its refracting surface is silvered. So suppose this side is silver, that is this surface will act as a plane mirror. Okay, now it says that light rays falling at an angle of incidence 2A, so angle of incidence on the first surface is 2A, returns back through the same path after suffering reflection at the silvered surface. So this is the silvered one is actually the second surface, and this one is actually the first surface. Okay, so light rays will come like this, and if this is the normal, then this will make an angle 2A, it's given in the question. Then after refraction, this will go and hit the second surface and then retrace back. Now here is the thing, we know that whenever, if this is a plane mirror, whenever light falls at 90 degree on the surface, then we know that light ray retrace back its path. Therefore we can understand from the language that the ray is incident normally on the second surface, isn't it? Okay, so we know that this is actually 90 degree. Okay, therefore how to find out the refractive index? We know refractive index is given by sin I by sin R, where I is the angle of incidence and R is the angle of refraction. We know that angle of incidence is given as 2A, but what is the angle of refraction? Is there any kind of relationship between R and A? Absolutely, we have learned this just a few moments ago, that R1 plus R2 is equal to A. Okay, this is the refracting angle in the first surface and this is the refracting angle in the second surface. Now we need R1 to find the refractive index. Now what is R2? If you look carefully into the figure, then we can see that R2 is equal to 0. Why? We know that whenever there is a plane mirror and a ray of light falls perpendicular to the surface, then we know that the angle of refraction is 0 degree. Okay, because the ray and the normal is on the same line. If it is on the same line, then the angle of refraction is 0 degree. Therefore, we can say that R2 is 0 degree. Therefore, we can conclude that R1 is actually is equal to A. Simple. Therefore, you can say that mu refractive index is equal to sine of 2A, because I is 2A, divided by sine R1, where R is actually A. Therefore, we can say that sine 2A is 2 sine A cos A divided by sine A. Sine A got cancelled. Therefore, we got 2 cos A is the refractive index of the prism. Therefore, 2 cos A is the answer. Now, here's the trick that you need to understand. Let me rub this part for you. So, let's understand the trick. Okay, so see, you did so much in order to attain mu is equal to 2 cos A. You thought R1 plus R2 is equal to A, then you understood that R2 will be 0, and then you got R1 is equal to A, then you put the value of R1 here, and then you got the result. Remember this trick because this is very commonly asked in NEET. So I'll put a star here and write down that whenever ray falls 90 degree to the second surface in prism, then R1 is always equal to A. Always remember, whenever the ray falls 90 degree, that is, it is incident normally to the second surface, that is, we can say R2 is equal to 0 because it is normal to the second surface. Then always remember, without thinking, since the ray in the second surface is 90 degree, therefore R1 is always equal to A. Just remember this technique. Therefore, we can directly say, whenever this kind of scenario comes up, that the incident ray is 90 degree in the second surface of the prism, then we can directly say that, okay, sine I by sine A, because R will be always equal to A. You don't need to put this R1 plus R2 is equal to A. Directly you will write that R1 will be equal to A. This is the trick you need to remember. Let's again look into a similar kind of problem, because this was again asked in NEET. See, this is very frequently asked in NEET. So this was asked in the year 2012. Okay, so it says a ray of light is incident at an angle of incidence I on one face of the prism of angle A and assumed to be small, and emerges normally from the opposite face. See, emerges normally from the opposite face. Again, we can see that the incident ray on the second surface is 90 degree. If the refractive index of the medium is mu, then the angle of incidence I is, and 4 options are given. So you can directly write mu is equal to sine I by sine R, and we know that since the incident ray is 90 degree to the second surface, therefore R will be equal to A. Therefore, we will directly write sine A. Okay, therefore we can write that sine I is equal to mu of sine A, isn't it? Now let's look into this condition. It says that assumed to be small, that is, the prism angle is small. Okay, we know that whenever the angle is small, then we can write sine theta is equal to theta when theta tends to 0, that is, theta is very small. This is the condition we have already learned in our previous video. Therefore we can directly say that, okay, I, angle of incidence, will be mu A. We just use this formula, sine theta is equal to theta. Therefore, sine I can be written as I, and mu of sine A can be written as mu A. Therefore, angle of incidence becomes I is equal to mu A. Simple as that. Okay, see how this trick is so handy. You don't need to think about R1 plus R2 is equal to A, then R2 will be 0, therefore R1 will be equal to A. Just you don't have time to think about that. Just equip yourself with this kind of trick so that you can use it directly in your exam and then tick the answer and move on. Okay, I hope this is clear. Therefore I'll repeat it, and so I'll repeat the concept again and we'll end this concept here, that whenever the incident ray is 90 degree to the second surface, always remember R1 will be equal to A. Okay, I hope the concept is clear. Now let's move on to our next problem. Okay, now let's look into this question. It says that the glass prism is actually an equilateral triangle and it is kept in air, as you can see. Okay, and the refractive index of the prism is given to be √3, and the angle of incidence on the first surface is 60 degree. These are all the given data, and the question is find the angle of emergence and find the angle of deviation. Now how to do that? This is a very common problem and can be easily solved. So let's see how to solve this. Okay, solution. In order to find the angle of emergence, we first need to find out the angle of refraction in the first medium. Okay, so how to find out the angle of refraction in the first medium? So the easy technique is use Snell's law. So we'll be using Snell's law. So refractive index of air multiplied by sine of angle produced in the air medium, that is 60 degree, is equal to refractive index of glass prism multiplied by sine of refraction angle in the first medium, that is the angle produced in the prism. Okay, this is how we apply Snell's law. And I said this is the best way of applying Snell's law so that you won't get confused. Okay, if you haven't gone through my Snell's law video of refraction, then please go through that and things will be very, very easy. Okay, now let's see. Refractive index of air is 1, sine 60 is √3 by 2 is equal to refractive index of glass is given to be √3 and sine R1, where R1 we need to find out. Okay, so √3 got cancelled, so you got sine R1 is equal to half. Therefore, you can say that R1 is basically 30 degree. So if this is the normal, okay, so we can say that this will be 30 degree. Okay, this will be 30 degree, and we can see that the ray has bent towards the normal because the glass prism is actually optically denser than air, and we know that when a medium is optically denser, then the rays after refraction move towards the normal. So simple as that. Now how to find out R2, that is angle of refraction in the second medium. So if this is the normal, okay, so what will be this angle? Okay, so you need to find out that. In order to find out R2, we have a relationship that is R1 plus R2 is equal to A. We'll be using this concept. Okay, so what is the value of A? If you look carefully into the question, then it says that the triangle or the prism is actually equilateral triangle. And we know for equilateral triangle, all angles of the triangle is actually 60 degree, isn't it? Therefore, we can say angle A is 60 degree. Or directly we can say that R2 will be equal to A minus R1. Now R1 is 30 degree, that is what we have found it here. Therefore we know that R2 is actually 30 degree. So simple as that. Now we can find out angle of emergence. So how to find out angle of emergence? That will be this ray and this will be the angle of emergence. Now I have drawn it in this direction because we know that air is actually optically rarer, therefore the rays after refraction will move away from the normal. Okay, so this is how the diagram will be. Now in order to find the angle of emergence, we will be again using Snell's law for this interface. Therefore the Snell's law will be mu of the glass prism multiplied by the angle of refraction in the second medium, that is R2, that is the angle produced inside the prism, is equal to refractive index of air multiplied by sine of the angle produced in air, that is angle of emergence. Okay, now refractive index of glass is √3, sine of R2. Now R2 we got as 30 degree, therefore sine of 30 degree is half and mu of air is 1, and we need to find out the angle of emergence E. Okay, now if we solve this, then we'll get that E is equal to 60 degree, because we got sine E is equal to √3 by 2, and we know that sine theta is equal to √3 by 2, then theta will be 60 degree. So we got E is equal to 60 degree. Simple as that. So we got the first part of the question, the angle of emergence. Now what will be the angle of deviation? Simple again, use the formula that I have taught you, that is deviation is equal to I plus E minus A. Okay, so if we use this formula, then we know that angle I is 60 degree, angle of emergence is also 60 degree, and angle of the prism is also 60 degree. Okay, so 60 got cancelled and we got the angle of deviation to be 60 degree. Simple as that. So the angle of emergence is 60 degree and angle of deviation is also 60 degree. Okay, so simple as that. This is how you need to find out these kind of problems. This is a very common problem, so you need to remember these concepts. Okay, now we'll be looking into a similar kind of problem, but it's a bit tricky. We'll be looking into that. So let's jump into that. Now the angle of incidence is given to be 60 degree, as you can see here. Okay, and the refractive index of the glass prism is √3 and the glass prism is kept in air. So what will be the angle of emergence? This is the question. So how to solve for this? We know that in order to find the angle of emergence, we first need the angle of refraction in the first medium, that is R1. So how can we get R1? The simple answer is apply Snell's law, as we have learned earlier. So we'll be applying Snell's law in the first refracting surface, that is mu of air multiplied by sine of angle produced in the air, that is 60 degree, is equal to refractive index of the glass multiplied by sine of angle produced in the glass, that is R1. Now mu of air is 1, sine of 60 degree is √3 by 2, mu of G is given to be √3 multiplied by sine of R1. Now √3 got cancelled, therefore you can say that R1 is basically 30 degree. Now if you draw this, you'll see what happens. Now if this is the normal, and you may be thinking, okay, now the rays will go and hit it in this surface, isn't it? So we got that this is 30 degree. Then if this is the normal, then we will get this as 60 degree, because 60 plus 30 will give us 90. If this is 60 degree and this is 120 degree, if you consider this triangle, this point, and this point, this is a triangle, then we know the sum of angles in a triangle is actually 180 degree. Therefore 120 plus 60 is 180. So what will be the third angle? 0 degree. So this is a trap. So that means since the sum of the angles is surpassing 180 degree or exceeding 180 degree, that means this ray will never go and hit this surface. Okay, rather it will go and hit this surface, because if it goes and hit this surface, then the law of triangle is actually violating. Okay, so let's see. Let me rub this off and draw the correct ray diagram. Therefore, the ray will actually go and hit it here. Okay, and this will be 30 degree, as we have got that R1 is equal to 30 degree. If this is 30 degree, this will be 60 degree. Simple as that. and this is 90 degree because this is normal. So the total angle, that is this total angle of this triangle, if you put this is one of the vertex, this is one of the vertex, and this is one of the vertex, then we'll get that 90 plus 30, this whole angle will be actually 120 degree. Therefore you can write this angle will be 120 degree, this is 30 degree, then this one will be 30 degree again, then the sum of all the angles will be 180 degree. Now the normal to this is this one, isn't it? So the refracting angle or the angle of incidence in the second surface will be, don't say that it is 30 degree, because we always measure angle of incidence from the normal. Therefore this angle is actually the angle of incidence. Now if this is the normal n, therefore this total angle is 90 degree, the down angle is 30 degree, so the up angle will be 60 degree. Okay, so this is what the angle of incidence, that is R2 in the second refracting surface, is 60 degree. Now once you know that this angle of incidence in the second surface is 60 degree, now how to get angle of emergence? Okay, let's see. In order to find the angle of emergence, you'll be saying that we'll be using Snell's law. So let's apply Snell's law here. So we know that mu of glass multiplied by sine of the angle produced inside the glass, that is 60 degree, is equal to mu of air, since the ray is going into the air, multiplied by sine of angle of emergence, because the angle of emergence is in the air. Now if we solve this, refractive index of glass is √3, sine of 60 degrees is √3 by 2, mu of air is 1 multiplied by sine of E. Therefore √3 multiplied by √3 by 2 is 3 by 2, so you got sine of E as 3 by 2. Now in the option there will be one option like this, E is equal to sine inverse 3 by 2. Now if you look into this option and tick this one, then you will get negative. If you look carefully, then 3 by 2 is actually greater than 1, and we know the sine value can never be greater than 1. Therefore this is again the second trap of the question. So this is actually wrong. This is not the angle of emergence. Now why here the sine of E is violating the law, that is sine of E is greater than 1? It's violating the law because in this surface it doesn't undergo refraction. This is why it is violating the law. Whenever sine of E is greater than 1, remember one thing, it is actually suggesting that in that surface it is not undergoing refraction. So the only concept left here is that if it is not undergoing refraction, that means it is undergoing total internal reflection in this surface. Therefore actually the ray will go and hit in this surface according to total internal reflection. Why this ray is undergoing total internal reflection? Because actually this angle 60 degree is greater than the critical angle of the glass prism. Okay, this is clear. Therefore we are getting sine E to be greater than 1. If this is 60 degree, then according to reflection law, the angle of reflection will also be 60 degree. If this is 60 degree, this has to be 30 degree. If this is 30 and this is 30, then we will get this total angle to be 120 degree. Isn't it? Simple as that. Now if we draw a normal on this, so this is the normal. If this is the normal and the total angle is 120 degree, therefore this angle will be 30 degree. Isn't it? Because this will be 90 degree, this side will be 90 degree, because that's the normal. If this is 30 degree, then we can find out the angle of emergence. The angle of emergence will be this one. Okay, and in order to find angle of emergence, we need to apply Snell's law in this refracting surface. So we'll be using Snell's law again. So mu of glass multiplied by sine of 30 degree, because that is the angle of incidence on that surface, is equal to mu of air multiplied by sine of E. Now mu of G is √3 multiplied sine 30 is half, mu of air is 1, and multiplied by sine E. So you got sine E is equal to √3 by 2, therefore E is equal to 60 degree. Therefore we can say this angle of emergence is 60 degree. I hope the concept is clear. Very simple. Just go and check the trap. The trap I have talked about. There are two traps in this question. The first trap is you need to check whether the ray will go and hit this surface or it will go or hit this surface. Okay, this is the first trap that I've spoken about. And the second trap is check whether the angle of emergence, that is sine E, is greater than 1 or not. If it is greater than 1, that means at that surface it is undergoing total internal reflection. If sine of E is less than 1, then at the surface actually refraction happens. Okay, if for this total internal reflection for this refraction. I hope the concept is clear. This is all about the tricky concept in this question. If you understand this question, then you are expert in the concept of prism for this concept. Okay, now let's move on and check the other concepts that are left for refraction in prism. Now let's move on. Okay, now let's look into the parameters on which angle of deviation actually depends. So there are 4 parameters on which angle of deviation actually depends. So let's look one by one. The first one is refractive index of prism. Now, how is refractive index of prism is related to angle of deviation? We can see I have written that if the refractive index is increased, then the angle of deviation also increase. That is, we can say that refractive index of the prism is directly proportional to the angle of deviation. Now, how is this? This is very simple. Let's take two medium. Okay, this is one and this is another. Suppose this is refractive index mu1, this is refractive index mu2. Okay, now I can directly say that if it's given that mu1 is greater than mu2, you can easily say that mu1 is optically denser than mu2, isn't it? Now, optically denser means the value of refractive index will be more, as we have said earlier in my lecture video. Therefore, you can say that for mu1, we can say sine I by sine R1, and for mu2, that is this medium, if we talk about, okay, both here is air, okay, for both the cases, okay, is equal to sine I by sine R2, isn't it? Now what I've done is I have kept the angle of incidence same in both the case, okay, and I got mu1 and I got mu2, and since mu1, that is the refractive index of this medium, is greater, optically denser than this medium, therefore we'll get mu1 to be greater. So mu1 is greater than mu2. Why? Because this sine R1 value is less than sine R2 value. Since this value is lesser than this value, we know that mu1 will be greater. Now if sine R1 value is less than sine R2, we can directly say that R1 is less than R2. Now what does this actually means? Let me draw it again. So suppose this is I and this is again I. We have taken two medium. This is for mu1 and this is for mu2. Now we got that R2 is greater. So this is R2 and this is R1. So we can say this angle is as R2 and this angle as R1. Therefore, we can see that mu1 will be greater because R1 is less, and we know that mu and sine R are inversely proportional, isn't it? Therefore, we can say that since R1 is smaller for refractive index, now since R1 is smaller, that means the deviation is more. You can see that this has deviated more and this has deviated less. So greater the refractive index, more is the deviation. Simple as that. Okay, I hope the concept is clear. So greater the refractive index, greater will be the deviation, greater will be the deviation, greater will be the deviation angle. So this is how you need to remember the relationship between refractive index and angle of deviation. So they are both directly proportional. Okay, now let's look into our second parameter on which the angle of deviation depends. And it says the angle of deviation is directly proportional to the angle of prism. Now if you look into this formula that delta is equal to I plus E minus A, you'll think that if A increases, then delta is decreasing. If you look into this formula that if A increase, we can see delta is decreasing, isn't it? Because greater the value of A, more is the subtraction from here. If more is the subtraction, then this will be decreasing. But actually this is not the case. It's experimentally seen that if A is increasing, then delta also increases. Now why? Because you're missing out something when you're looking into this formula. Actually, when you are increasing A or decreasing A, that is basically varying A, then E also changes, because we know that A is dependent on R1 plus R2, isn't it? So and we know that when we are finding E, then what happens? We use Snell's law and we use R2 in order to find E. That is mu of glass sine R2 is equal to mu of air sine E. This was the case. So R2 is dependent on E. So we can see that since R2 is dependent on E and R2 is also linked with A, so when we increase A, then basically E also increases, as a result of which delta increases. So I'll put a star mark here. So this is very important. You need to remember this and put a star mark so that you are extra caution when you revise this concept. Okay, so the angle of deviation will increase if angle of the prism is increased. So this is very important. Now let's move on to our third parameter, that is wavelength of light. Okay, now it says that wavelength of light is inversely proportional to angle of deviation. Now why is this? We have seen that delta increases if refractive index increases. Now let's understand. We know refractive index is inversely proportional to velocity, isn't it? And we have seen this derivation that mu1 by mu2 is equal to v2 by v1. This has already been derived in my first concept of refractive index. Now, since refractive index is inversely proportional to velocity, and we know velocity is equal to frequency multiplied by lambda wavelength, therefore we can see v is directly proportional to lambda. If v is directly proportional to lambda, therefore we can directly say mu is inversely proportional to lambda. If mu is inversely proportional to lambda, and we can see that delta is directly proportional to mu, therefore we can say that from this and this, if we combine, then we can say that delta is inversely proportional to lambda. That is, we can say that if we increase lambda of the ray of the light, then angle of deviation will decrease. I hope this is clear. Now let's look into this visible spectrum of light, that is VIVG, or violet, indigo, blue, green, yellow, orange, red. And we know that red light has the maximum wavelength and violet has the minimum wavelength. Since R has the maximum wavelength, therefore lambda is max, therefore we can say that red light will have minimum deviation or the least deviation. I hope this much is clear. So I have written down here that deviation for violet light will be maximum because the wavelength of violet light is minimum, and the deviation of red light will be minimum because the wavelength of red light is maximum. I hope this is clear. So this is the third parameter on which angle of deviation depends. Now let's look into our fourth one, that is angle of incidence. So the fourth parameter is the angle of incidence, and there is no such strict relationship that if angle of incidence increases, then deviation will increase, or if angle of incidence is increased, deviation will decrease. That is no direct comparison like it's directly proportional or inversely proportional. Okay, so it is both. So let's analyze that. If you look into this figure, then we can see that if you look into the first ray, that is green color ray, okay, so you'll see that the angle of deviation is this much. Okay, this is the angle of deviation. Now what we did is we increased, this was the angle of incidence. Now what we did is take the pink color ray, we increased the angle of incidence, so we saw that the angle of deviation has decreased. Now we took the yellow color ray and we found out that the angle of incidence is more increased, so we got angle of deviation is this much. That is, we can say that the angle of deviation has decreased. Then we increase the angle of incidence more. Now we have increased this to this much, but now we see that the angle of deviation this side, instead of decreasing, it has increased. For the violet ray, we are increasing the angle of incidence more, but we see that the angle of deviation has increased more. So we saw that initially, as we are increasing the angle of incidence, the angle of deviation was decreasing. And after a certain point, when we are increasing the angle of incidence, then the angle of deviation also starts increasing. Okay, so this was the experiment done. And when we plot these experimental values on the graph, then we got a graph of this nature. That is, if we take this y-axis as the angle of deviation and the x-axis as the angle of incidence, then we can see that as we are increasing the angle of incidence, we see initially the angle of deviation is decreasing, isn't it? And then a point comes at which angle of incidence, the deviation is minimum, after which if we start increasing the angle of incidence, then we see again the angle of deviation starts increasing. Okay, so this is the graph. So we can see that there is only one value of angle of incidence for which the angle of deviation is minimum. Very important. Okay, now let's summarize the conclusion that we have obtained from the graph. That is, the number one is the angle of deviation is minimum for only one particular value of angle of incidence, as we have seen here. Okay, and we can say that delta will be delta minimum, and the condition that we have seen or we receive is that I should be equal to E and R1 should be equal to R2. If these conditions are achieved, then we can say the deviation that will be produced is actually minimum deviation. Okay, and this can be proved geometrically. Very easy, that for minimum deviation, since there is only one angle, therefore I and E has to be same, and R1 and R2 will be same since I and E is same. Okay, so let's leave that part as of now. Just remember that the condition for minimum deviation is that I should be equal to E and R1 should be equal to R2. Let's jump to our next point, that is for each value of delta there are two values of I except for delta minimum, as I've explained in the graph and showed it in the graph, that for each value of delta there are two values of incidence, as I have expressed or presented the concept using this and this point. Okay, that this delta have angle of incidence as this and this. So there are two angle of incidence for a single angle of deviation, but the exception to that is delta minimum. For delta minimum we'll only get a single point of angle of incidence. I hope the concept is clear. Now let's move on to our next concept, that is finding the value of refractive index of the glass prism or any prism in terms of delta minimum. So we'll be looking into that. So let's move on. So now let's look into the concept of refractive index of prism in terms of minimum deviation. All the formulas that I will be using has already been discussed, and I hope you have gone through the full video. If you have gone through it attentively, then this is just a piece of cake. So let's use the formulas that we have already derived to find out the refractive index of prism in terms of minimum deviation. So let's see. We have already seen that delta deviation angle is equal to angle of incidence plus emergence angle minus of R1 plus R2, where R1 and R2 are the refracting angle in the first surface and the second surface. Okay, this was the formula that we have derived. So we said that there was a condition for minimum deviation. What was the condition? So let me write it down. Condition for minimum deviation is that I should be equal to E and R1 should be equal to R2. If this condition is satisfied, then we say that the angle of deviation is minimum for that prism. Okay, so let's see. If we put this equation here, then what we will get? We will get delta minimum is equal to, since I is equal to E, we can simply write I plus I will be 2I minus R1 is equal to R2, therefore we can directly write it as 2R. Okay, so this is what we got as minimum deviation. We have also seen this formula, that is R1 plus R2 is equal to A. Since R1 and R2 are equal in case of minimum deviation, therefore we can say that 2R is equal to A, isn't it? So if we put this value here, then we will get that delta minimum is equal to 2I minus A. Okay, from this equation we can find out angle of incidence as dm plus A divided by 2. Similarly, if we use this formula, okay, that is R1 plus R2 is equal to A, for minimum deviation we know that R1 is equal to R2, therefore we can write that 2R is equal to A. From here we can write that R is equal to A by 2, isn't it? I hope this much is clear. So we got the value of angle of incidence and we got the value of angle of refraction. Now in order to find refractive index Ri for prism, we know that refractive index is given by the formula mu is equal to sine of I divided by sine of R. This is actually Snell's law. Therefore, you can just put the value of I and R in this equation to get the result. So sine of I, we have found out the value of I as delta minimum plus A, that is angle of prism, divided by 2. And for sine R, we will put the value of R as A by 2, that we have derived it here. Okay, so we got that refractive index of the prism is given by sine of delta minimum plus A divided by 2 divided by sine of A by 2. This is the formula you need to use. So I won't be giving any kind of numerical problem, because if questions are asked from this part, then it is basically formula based question. So they will give you the value of dm or A or sometimes mu, and they will tell you to find out one of the unknown parameter of this formula. So it's simple. If you know the formula, then you can solve question from this part. So easy as that. So this is all about the refractive index of the prism in terms of delta minimum. Now let's look into our final problem, that is how will this formula change if we use thin prism, or basically we can say that what will be delta minimum for thin prism. Okay, this is the heading. So let's see, what do you mean by thin prism? First thing that we need to understand, see, a thin prism is a prism in which there are two conditions, that is A, the angle of prism will be very small. Okay, this is the first condition, and the second condition is that the delta minimum deviation will also be very small. Okay, so let's see how will this formula change, and with this formula we can find out the value of delta m for thin prism. Let's see. Now mu will be equal to, we know that mu is equal to sine I delta minimum plus a by 2 divided by sine of a by 2, as we have seen earlier. Now we know that since a is very small and delta m is very small for thin prism, therefore we can say that mu can be written as delta m plus a by 2 divided by a by 2, isn't it? We know this, that we can omit sine. We can write sine theta as theta when theta is very small. We have used this concept. So I'll write it down for you, that is sine theta is equal to theta when theta is very small or theta tends to 0 degree. This is the concept of maths. Okay, therefore we can now write that, arrange this thing. So 2 got cancelled, and if we arrange the thing, that mu a is equal to delta m plus a. Now from here we can write delta m is equal to mu a minus a, or we can say that delta a minimum deviation angle is, if we take a common, then mu minus 1 multiplied by a. This is another important formula. So this is the formula for minimum deviation when the prism that we are using is very thin. So the two things that you need to remember is that, since you already know this formula, just you need to remember that a will be very small and dm will be very small, and then use this concept, okay, to find the value of dm, that is dm is equal to, or delta minimum is equal to, mu minus 1 multiplied by a. I hope the concept is clear. So you need to remember this formula. See, I'll tell you again that in NEET, they will never ask very difficult question. They will ask question that can be solved within 1 minute. Okay, most of the questions are formula based. So if you remember those formulas, then you can easily solve those questions. Okay, the challenging part for a student is to remember these formulas. See, the subject is not tough, or the concepts are not tough. The toughest part of the subject is that you need to remember all this formula, because the number of formulas are very high, because after completing 26-27 chapters, that is combining class 11 and 12, things becomes really tough to remember all these formulas. So you need to find out a way so that you can remember all these formulas. If you can remember all these formulas, then I can absolutely say that you can solve most of the question that is asked in NEET. Okay, that's all for this video. If you enjoyed this video, then please give it a thumbs up, and if you haven't subscribed to this channel, then please consider doing so. Till next time, enjoy your studies and build your concept, and I will catch you all in my next video. Bye bye.